Greetings, welcome. A little bit different start to the video this time with the intro. And what am I doing? I'm rebuilding a Arduino battery capacity tester. So I talked for like a half hour on this, and I realized, people probably don't care that much about it. So I'm going to try and give you the Cliff Notes version. This one will probably end up being an hour. But I'll try and tell you quickly, what am I doing, why am I doing it, how am I doing it. So I just gave you the what am I doing is I'm building a battery capacity tester. You can buy off-the-shelf ones for like lithium ions. I don't see them for the 9-volt ones. And I want to use these 9 volts because they don't have, this is like 250 milliamp hours. A lithium ion might be like, 3,000 or something like that. So if you're running a motor, you want to get your answer quickly, which means you want the batteries to change quickly. And once you have this set up, it'll work for any batteries right now up to 10 volts. And if I did a little switcheroo with the resistors, then any batteries up to 20 volts. So then it's a universal battery capacity tester. So what was I doing in the intro there? Okay, you have your analog digital converter chip that goes between there are 5 pins for it. So I'm using 2 of them, pin A0 and pin A1. If you put a voltage between 0 and 5 volts across, we'll say the A0 and the Arduino ground, it divides it up into 1024, and then it'll spit out a number depending on what voltage it's seeing. So if you put 2.5 volts across there, you're going to see it spitting out 512. It's actually not as accurate as an actual good meter. But what you can do is measure the value, say, of the battery on your meter, see what this is spitting out, and then just adjust it, calibrate it to be putting out the same value as the multimeter. So that's all well and good, except for if you go up to 9 volts or 10 volts, the Arduino isn't meant to handle that, and so you're just shooting 5 volts back into the Arduino, which will likely fry it. And it's not going to go above the value it's putting out for 1024, so you can't figure things out, and it fries it. So what do you do then? You make a voltage divider. And so voltage, current flows from high voltage to low voltage. At the midway point of the journey, the voltage is only half as between the 2 points originally. So you put in 2 resistors of equal value, and now you see that the ADC pins are not going out to the battery, they're going out to the midpoint of where those 2 resistors meet for each of those. So now you can go from 0 to 10 volts, and when it's spitting out 1024, that would be 10 volts, and 5 volts would now be 512. So again, I found that the ADC was off by like 5 or 8% as compared to what I was getting here, but it's not, you can just fix it in the software. So in other words, if this thing is saying, if you're at 5 volts that you measure on here, and this thing is spitting out 600 instead of 512, then you just do a little bit of algebra and you figure out, well, this is actually what you want to divide it by so that it matches here. And so I have these things dialed in about as well as I can with this one and this one. And it doesn't have to be perfect, it just has to be consistent. So now we can measure the voltage of any batteries up to 10 volts. And again, if you change the resistors, you can go up to 20. So that's nice. Now, how do we figure out the capacity or the milliamp hours of each? So let's pretend this is a 10 volt battery, and you put a 500 ohm resistor across it. V equals IR, I equals V divided by R. So that means that you are putting a load of 20 milliamps across the 10 volt battery. So you look at it, and then you go away, and you come back in an hour, and let's say it's still at 10 volts. Then you say, oh, this thing has at least 20 milliamp hours in it. But, maybe the battery is garbage or is surface charged and it's dead. Or maybe it's gone to 8, in which case, if it went down evenly the whole time, you didn't actually get 20 milliamp hours out of it. You got the average between 10 and 8, or 9, you got 18 milliamp hours out of it. So you don't really want to sample once an hour. Now with the Arduino, you could, sample once a millisecond or faster, but that's sort of overkill. For what I'm going to show here, I'll show it sampling once a second, but once I get it running, I'll probably just have it spit out a number once every 10 seconds, which is fine. So every 10 seconds, it'll say, okay, that's how much milliamp hours we got out there. And then it puts that in a variable and stores it, and then it looks at the next 10 seconds. All right, the voltage went from 10 to 9.9, and then 9.9 to 9.8, so that's how much we got out the second interval, and it adds it to what it got out the first interval. And so you keep a running tally of how many milliamp hours you're getting out. So that explains the resistors and things like that, which I'll show you in a minute. So what are the two switches doing there? So we're going to want to be able to have two batteries going at the same time, but one for each switch. And you put it in there, and you also tell the code, well, if this battery has gone down to, let's say, 6.9 volts, it's dead. And then you shut that switch off. Because already more than once with these batteries, I want to I'm going to do some battery charging, and I charge a couple up on the wall, and I put a couple where I just drain them out through a resistor, and I forget about them, leave them overnight. I come back and they're at like 2-3 volts. And then, you take the resistor off and it rebounds to 6 or 7, but did I ruin the battery? And so then you're kind of stuck you run the thing, oh, the battery went way up. Is it the battery just garbage now, or are you actually getting anywhere? So what you can do, and to go back to the why am I doing this, I've got like a dozen of these, maybe 10, but somewhere around there. Put each of them on the wall, charge them up, then I'm going to discharge them. And some of them, the rated capacity is 250 milliamp hours. Some of them might be like 100 now because I've overcharged them or something. But I'll know with each of them. And so then, you take one where you say, all right, I know there's 200 milliamp hours in this one. That's my run battery. I know there's, 205 in this one, 195 in this one. And you see what you get. And then after that, you'll run it until it goes to the same voltage. Well, we're not there yet, but the same 7 volts, and say, okay, now the battery's dead. And then you just take the ones that you charged and put them on here. So now milliamp hours you expended and milliamp hours you got out. And maybe you do really well, maybe you do really poorly, but at least you have a way of looking at things, and that doesn't take 2 weeks. And if you make a change, then you can see, oh, am I going in the right direction or the wrong direction? So we'll talk for a quick minute about the code, and then I'll show you the thing in action. So there actually are a lot of variables here, but what we're doing, because there's 2 of them, I just cut and paste this. We do it once with one channel, and then we just cut and paste the same code and do it again with the second channel. So if we say if the sensor value is greater than 750, and that is approximately 7 volts, right around 6.9 or 7 volts. If your sensor value from the ADC is greater than 7 volts, and put in this variable, this toggle is 0, then wait 10 seconds. Now you're going to have your voltage equals the sensor value divided by, and this number is, when you're calibrating it to your multimeter. So you have your voltage. Now the milliamps is going to be voltage divided by resistance. The resistance are these two 220 ohm resistors for a total of 440. The sampling is coming from the midpoint, but we're going to run the battery through both of them. So 440 ohms of resistance. And so, it's in the ballpark of a 20 milliamp hour draw. So that's your milliamp hours. That's your, milliamps that's going on. And then milliamp hours is equal to that voltage divided by resistance times, and this number is going to depend on how long your delay was. So in other words, if your delay was an hour, then this would be voltage divided by resistance times the 3,600 seconds in an hour times 1,000 again to get to milliamp hours. But we're going for 1 second, and so it just turns out to be that. And when I go to 10 seconds, that just becomes 2.78. And then here's your scribe part, where it just keeps track of, all right, total milliamp hours equals what it was before plus this new one. And then you just have it printed. And there's an else part to that if statement where you say if the voltage goes below 7 volts, then you turn off pin 13. So you turn off the solid state relay so the battery is no longer connected and you're not still draining the battery out. And then this is just a little LED that I have that lights while the thing's running and then shuts off. And then lastly, we have this toggle, which I haven't talked about yet. Now you set the toggle equal to 1. And why are you doing that? And if we go back to the original statement, we say greater than 7 and toggle equals 0. So now toggle equals 1, so it doesn't go back in there. And we defined it as 0 initially. So the reason I'm doing that is, when you take a battery off of the load, it rebounds back up. So here it would shut off when it reached 7 volts, and then 10-20 seconds later the battery would be back at 7. It'd start up again for a little while, and then it'd shut down, then it'd start up. It would keep kind of rattling around there at 7 volts as the battery kept trying to rebound. So we're just saying once it reaches 7 volts, and I may change that. I may make it like 6.5 or 7.5, but 7 sounds nice. Then shut off and don't care about the battery anymore. Even if the battery rebounds up to 8 volts, don't turn back on again. So that's why there is that toggle. And the last thing, and this was like a gopher hole for me, and I didn't even know you could do this. In the setup part, you can say what you want a pin to be doing. So you put pin 13 high in the setup. So in other words, this thing starts with this open, because otherwise I'm not sure why, but it didn't work. The switch would never turn on, and I'm not sure why. Somehow it feels like the first loop through it just has the sensor value at 0 or something like that. But in any event, it works now, and let's show it to you working, and we'll demonstrate it with the power supply first, and then we'll throw a couple batteries on and kind of show you how this is going to work. So here we have our power supply. The voltage is at 9 volts. It's going into here, and then the ground is going to the Arduino ground. And for the 2 batteries, I have one yellow line going to one of the switches and a second yellow line going to the second switch. So when we compile this, because right now it's not doing anything, now we see a couple things. Our LEDs came on, indicating that the contraption is working, and we see that we're now drawing 40 milliamps, and so 20 milliamps draw across each of the channels. So that indicates it's working. And the neat thing is when we go to the serial monitor. So here's what we're getting out of the serial monitor. And again, I'll probably make it only go once every 10 seconds instead of once a second. But it's saying battery 1, there's your voltage, and here's the milliamp hours. Battery 2, there's your voltage, there's the total milliamp hours you've gotten out so far. And it just keeps that running tally. And if we want, we can even put the timestamp part on. So you can say, well, the battery lasted for an hour and 20 minutes, and we got this many milliamp hours out. So now let's pull one of these lines out so that one of the channels isn't seeing any voltage. And what do we see? It'll take a while for it to go through, but you can see down here, it just stopped printing. It's no longer tracking battery 1. Now it's only tracking battery 2. And so it's like that battery went dead, that LED went off. So we're at 9 volts. Now let's take it down to 7.8. We're still going. Let's take it down to 7.1. We're still going. Let's fine tune it. Right at 7 volts. It cut out. And now we're not printing anything anymore. And so your batteries are saved. You look at the last line that you got out here. You can scroll through it and you say, okay, that's the capacity of that battery. Now, where did the other one stop? Oh, it stopped up. That's the capacity of that battery. So now let's try it with a couple batteries. I'm not sure what they're at. And one of the things that annoys me and I have a problem with is all of the battery caps for these 9 volts. They have this flimsy, tiny hair-like wire at the end, and it's hard to get a good connection that stays. I should actually probably try and fire up the solder machine, but I'm not like Mr. Solder or anything. I could probably do it, but it's like, is it really worth it to spend that time soldering those things? But this is the best I can come up with, but hopefully they're actually connected. We're all set. All we have to do now, if this works, is compile, and we'll know from our lights in a moment. Yeah. Now we go out to our serial monitor. Okay, no, that was left over from before. And we know what battery 1 is. We know what battery, they're both around 8.85, 8.94. These were ones that were dead and were charged from the spike previously, so it'll be fun to eventually let these run and see what we get. So I'll probably take the sample time out to like 10 seconds or a minute, but just to finish the video up, let's make the sample time 5. Now we need to remember to times this by 5 and to correct that for both channels. Okay, if all goes to plan, when I compile this, it will spit out for us every 5 seconds what's going on. So the lights are on, wait for it. There we go. Battery 1. Battery 2. And that'll keep going every 5 seconds.